We're going to go back into the past. We're going to go back to Algebra 1. And I know this is an area a lot of Algebra 1 students struggled with, but it's one of those key things you just have to know for the semester. So I want to encourage you right now, if you are really struggling with radicals, I would love to help you. And if I'm not available, I know Mrs. Prempis will help you. Mr. McDonald will be there for you. We don't want you to feel lost. And I feel just really strongly about you guys understanding this, but I also feel greatly that you need to know how to do these. And first of all, I just want to make sure that you understand what taking a square root is. A square root is the radical sign here, is when we undo numbers being multiplied, basically, and we look for pairs of numbers. And so the first thing, in order to be able to do this, you have to know your perfect square numbers, okay? So here's our perfect square numbers, okay? And there's a list way back in the back of my room, but it's hard to see. You have your backs turned to it, so we're going to put it on the top here. And you need to know all of them. My husband's texting me. He's wanting to know about supper. From basically 1 squared to 20 squared. One in my room is all the way up to 25 squared. So we're just going to write these down. It's sure going to help us later be able to work with these. So I got 9 squared, 10 squared. I'm just going to go ahead and list them all the way through 20 squared. 16 squared, 17 squared. Make sure those are up there. Yeah. 18 squared, 19 squared, 20 squared. All right, now let's fill these in. They're not hard. Many of you have a lot of these memorized from last year, or you can even do the multiplication quickly in your head. Basically, we probably can get to 12 squared, and most of you know them off the top of your head. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared, 256. 17 squared is 289. 18 squared is 324. And then 19 squared is 361. And 20 squared is 400. And we're going to be looking for those. We're going to look for numbers that have factors of those. Now, I want to sit there and we're going to go through, and I want you to understand, I'm teaching this like you've already done it before. Basically, I'm teaching you about a week's worth of stuff you learned in one day. So if you don't remember it, you got to come in and get the help, okay? And I'll promise you too, if this is not a good day for you, we'll try again later in the week. We want to make sure you really, really understand these. So what's the first thing you must do? You must always simplify. It has to be in the simplest form, and that means you take out all perfect square numbers. Now, someone asked me the other day, why do I have to do these? Because of geometry. Right triangles, the Pythagorean theorem, we have to work with radicals all the time. So, I mean, that's the biggest why. Why you learn in Algebra 1 is because you're going to get it in geometry, and it's used in every math class from here on out. So I just want you to be very confident in it. Let me give you an example what I mean. This is the best method. I'm going to show you 2 different methods, but I'm going to show you the one that most of you probably learned. So here's example 1. This is the best, okay? Here, if I had take the square root of 8, okay? 8's not a perfect square number. Now, if I went over here and I said, oh, the square root of 9, every one of you would go, all right, here's 9, the square root of that would be the number 3. No big deal. But 9's a perfect square number. 8's not. So I look over here and say, is there a perfect square number smaller than 8 that I can factor out of 8? And almost every single one of you said, yeah, 4. Or someone would go, 2. 2's not a perfect square. 4 is. But I rewrite it as square root of 4 times the square root of 2. What's the square root of 4? 2. So 2 root 2. That is in the simplest radical form. Now, some of you were taught a second method, and it's using the prime factorization. So if I had the square root of 8, you would have to rewrite it as 2 times 2 times 2. All right? Now, here's the problem. You look for pairs of 2's. And when you have a pair, you take it out. They become like 2 becomes 1. It's like going to the chapel and we're... Okay, never mind. Biblical, let's just think about it. What happened is they come out 1. So you get 1, 2 out here. What's left is the old maid. 2 root 2. Now, the fastest method in the long run, because numbers will get larger and larger, will always be this first one. So if I was going to do this, or if I was going to learn it, if you had to relearn it or whatever, only do the first one. But that's where your calculator is going to be handy, because you're always going to try perfect square numbers with it. And sometimes you might pick one, but it might not be big enough, so you're going to have to do it more than once. All right? So here's another example. When adding or subtracting radicals, one must have the same number under the radical. Okay? We have to have the same number. Here's an example of what I'm talking about. When you're adding or subtracting numbers, you always have to simplify each radical first. But if I have something like this, these are called like terms. They have the same number underneath. So when you do that, you just add the coefficients, because that's addition. 2 plus 3 is what? 5 root 3. Now, the example for the other one. If I have 2 root 2 plus 3 root 3, I have to ask, are these the same? First of all, are they simplified? Yeah, those are simplest form. There's no perfect square numbers. They're not the same number, so I can't add them. That would be the simplest form. You can't do it. All right, so that one stays the same. So that's kind of a rule we've got to know. Another rule you're expected to remember is you must always rationalize the denominator of the fraction. You cannot leave a radical in the denominator of a fraction. Let me give you an example of this. 3 divided by root 2. Now, square root of 2 is in the simplest radical form, but the problem is it's in the denominator. So what you do is you just multiply, okay, by that radical in the denominator, all right? Or multiply by a number that makes it a square number, but we're not going to worry about that. So to do that, I have to multiply by root 2 times root 2. I'm actually using the idea of squaring a square root is the process that I'm doing. Then you multiply straight across. That's going to be 3 root 2 over root 2 times root 2 is going to be 2. Really, here's the y. What's root 2 times root 2? You multiply the numbers underneath together. That's actually the second one. Okay? And that means that becomes the square root of 4, which equals what? 2. All right? So that's where the rationalizing the denominator comes from. Now, actually, I should have probably put number 3 and 4, switched them around, but I'm going to sit there and just remind myself later to do it differently. But this one is multiplying radicals. When one multiplies radicals, first multiply the coefficients, the numbers out front, okay? And then multiply the numbers underneath the radicals together. Here's an example, real simple. 3 root 5 times 2 root 3. All right? So I multiplied the two numbers out front. Now, there are fancier names than coefficient, and I'm saying it wrong. I'm being the bad geometry teacher and ignoring the numbers. But we're going to multiply 3 times 2, which is 6. Then we're going to have our square root. I'm going to multiply these two numbers together. What's 3 times 5? 15. Now, before I am done, I have to double check something. I have to ask, is there any perfect square numbers that are factors of 15? I have 3 and 5 are factors, but are those perfect square numbers? No. So you are in simplest radical form, and you're done. Right, that's it. No calculators, however. Notice calculators will only help us reduce it. We're going to leave it what's called in simplest radical form, which means we're going to have radicals, no decimals. So on this next one, let's just practice reducing these. Obviously, what's the square root of 64? 8. Right on. Great. But notice I go over here, and I don't have a perfect square number. So I go up here to my perfect square numbers and go, what's a number lower than 24 that goes into 24? That's a perfect square. 16 doesn't work, 9 doesn't work. Oh, 4 does. So I rewrite it like this with a factor. I go square root of 4 times the square root of 6. It's like I split this one, okay? Then I go 4, what's the square root of 2? 2. Once you take a square root, the radical sign goes away. Number one error students make, they leave a radical sign. Stop it! Okay? And then the root 6 stays the same. If you go straight down, it helps you out. 4 times 2, 8 root 6. Now 6 is a number that, yes, has factors, but not perfect squares. So 8 root 6 is your answer. Let's try number 3. Oops, I totally didn't show you any of that, so let me show it to you again. I pulled it down. Here we take our 24. I split it 2. I get 4 root 6. I take the square root of 4, which is 2, and multiply them together now. 4 times 2, which is 8. The radical 6 just comes along to the right. It has no other perfect squares out of it. I am so sorry. I did not look up and see that I had that mistake on there. So please forgive me. We'll fix it for the next problem. The square root of 75. Is there a perfect square number smaller than 75 that goes into it? Any of these work? 25. So we take the largest one. So we got the square root of 25 times the square root of 3. It's kind of like I unmultiply them. I factor them out, right? What's the square root of 25? 5. So it's 5 root 3. All right, I hope that helps. All right, we're going to do all the problems in the next ones on the back side. I just want to make sure we have all those. That's examples 4 through 12 of doing all the types of problems you need to be able to do.